So at this point, we have completed the geometry for our benches. We've got the one bench constructed down here at our origin, sat up on the construction plane, orientated to accommodate the angle of our first column, and then duplicated to each row in column 1 and properly sized to its respective row. Then we've taken all of these benches and we have duplicated them around to each of the remaining columns. How do you like that for a quick recap?
That's fantastic.
So what are we going to do in this video? Most people would think start on the crowd because now we need some people sitting on the benches. But before we do that, this is kind of like a bonus video. Steve and I thought it would be really cool if we added support beams into the stadium. That's right, we are revisiting the stadium. I know we said we were done with the stadium, and to be honest, we are. We could simply move forward with the project, and this wouldn't hurt us if we did not have the supports in there, but we thought it would be aesthetically pleasing.
Yeah, and it just shows some extra cool techniques of working with networks in Houdini.
Without a doubt. So in this video, we will be reusing some of the information used to construct our benches and determining how we're going to place our support beams onto each of the undersides of our stadium. Though I do want to point out, this side right here, no support beams. It wouldn't make any sense because the bottom right here is going to be sitting on the ground. We've already seen that with our floor object custom parameter that we've created. But from this point up, we need to have support beams that come down to the ground as well for that extra stability. So with that, let's go ahead and jump over to the whiteboard and start talking about how we're going to pull this off. For starters, let's go ahead and throw in a new layer real quick so I have a clean slate to write on. And let us draw out the original profile curve from which our stadium is constructed. Starting off at the very beginning, we all know that we have this 1 unit curve that we created that represents row number 1. If we were to turn around and come in here with row number 2, it would look like this. Now at this point, let's take a look at what the bottom curve looks like. So as a quick reminder, the bottom curve looks like that. The first 2 rows, the bottom of the stadium sits on the floor. I'm going to straighten that up a little bit. I didn't realize it was quite that crooked.
Which, as we said a second ago, means we do not need support poles for these first 2 rows.
Exactly. So now if we were to go up to a third row, what happens with the bottom side? The bottom side is going to go up 1 unit and over. So now let's say we go up to a 4th row. So we go up 1 unit and over. And again, because of the way that we are creating the profile curve, we go up 1 unit and over. So let's say that we only have 4 rows in this particular case. We know that through the manipulation of some points, or a point, we end up closing the whole thing off, and we have this profile curve right here. So in thinking about support poles, we know that we need a support pole right here, and we need a support pole right there. Again, this is just a side view of what we'd be looking at. We need 2, of course, for each of our columns on each of the rows. But how high do these guys need to be? And how do we come up with that kind of information? Well, let's take just a second and see if we have something in common between this guy and all remaining rows that would be constructed. Well, we do. Take a look at this. What is the height? Actually, we can start all the way down here. From bottom to top, 2 units. Because this, again, was our unit row. There we go. I like that name. So moving up, that distance right there is 2 units. This distance is 2 units. So 2 units is about to become very important. Why? Well, let us jump all the way back to the bench. We're going to revisit the bench. With the bench, we started out, had a box, got the box properly sized, and then we came in there and we created a tube that was sitting down below, and then we told it to move up. So the tube was then positioned in such a way that it is sitting on top of the origin, and then we move the tube over to the side. So we'll go ahead and position the tube over to the side, like such. But once again, he is sitting on top of the origin. Now, for each bench that is sitting on top of a row, where the bottom of that row needs a support beam, we know that our support beam needs to start 2 units down. Why is that? Well, we've already defined that information right here. Because again, let's just take a look at row number 3. We have our tube, our bench sitting on top. there is no reason for the support pole to begin until, ding, 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 we come all the way down 2 units, and then we create it right here. Then somehow we need to know how far to go down to get it where it is sitting on the floor. Same thing applies with row number 4. If we have our tube, again looking at a side view, here's our bench. Same magical number, 2 units down, ding, 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 and that is where our support beam needs to begin, and it needs to extend all the way down to the floor. So, again, keep in mind this is the origin, but I'm going to use that line for dual purposes. 1, the origin. 2, to represent a row surface that the bench is going to get copied on. So we know that 2 units below this guy, 1, 2, is where our line is going to end up needing to go. And I said line. Where did line come from? Well, we're going to use a line, and we're going to use a circle, and we're going to sweep that circle along the line to give ourselves a tube. And this is going to work out really well. So let's go ahead and start out with that. We're going to begin with a line. So we'll throw a line down as a brand new start of a network within our network. And this line has a few very important pieces of information that we need to set. First of all, we're going to start with a direction. Which way is the line running? Well, we know that this is Y, and going back in this direction right here is negative Z. So I need the line to run down. So we're going to create a line with a direction of Y being set to -1. So that means X and Z will be 0, of course. So now we have a line going down, and by default, the line size is 1. The distance is set to 1. And that's irrelevant here, as you guys are going to find out very soon, because we, in the end, are going to care less about the line size. We're going to affect one of the points on the line to put that point down on the floor, not caring where the top is, because the top is being handled by another part of the network, as we're about to see. So that's the first thing we need to worry about. The second thing, we need to worry about where this line gets constructed to begin with. So the geometry that is coming out of this node, where is it positioned at in the world? Well, if, once again, this guy is our origin, we need to position our line to start with 2 units down in Y. So we can come over here and we can set our origin for Y. Oh, Y. That's pretty funny. Oi! We can set it to -2. Okay, that was actually a good one. So, set to -2 down. That gives us the distance. If I was to draw this out, what thickness do we have right there? That's the thickness of each of our rows if we were to do a cross-section of the stadium on any of the columns. Again, here's that cross-section. So let's take a look at this. 2 units. So we've moved him down. And check this out. This is where everything's going to become clear. Notice how I'm drawing 2 points right there. We said that we wanted this guy to go negatively. Here's why it needs to go in a negative direction. This first point is point 0. The second point is point 1. This is very important to keep in mind, because so far, every time we've been constructing stuff, if we're dealing with the y-axis, we're used to seeing 0 as the first guy and then going in this direction. So it'd be 0, 1, 2. So in quickly looking at this line, one might think, well, there's 0, there's 1. Okay.
It is worth noting that choosing a direction of negative Y as opposed to positive Y was just a personal preference.
Absolutely.
You could completely construct this network, making a few alterations to some of the parameters we used by going in the other direction.
You could, but in this case, I think it makes a lot of sense.
Yeah, I do too.
And I like that. Okay, so now that we have this guy going in a negative direction, like I said, our distance is already going to be a value of 1. We're just going to leave that. The next thing we can do before we leave this node is properly position him. Now, we know that there is a tube node that is sitting over here. And on the tube node, we basically centered it up right here on the box. So it's been moved over and positioned properly. So all we need to do is respect where it's at, basically an X. Now remember, just so that nobody gets confused, we're dealing with Z down here, but looking at our bench, we were working in the X direction. So just take the translate X of the tube where he's at, and let's take our line and move him over to there. And if we do that, we'll now find that our line has been positioned right here. So that works out quite nicely. Now, before moving on, because if you haven't figured it out yet, I'll go ahead and spoil the fun. We're going to be treating the tube and the line together as one, so that as we duplicate the tube all over the place, okay, because we know we have a whole bunch of tubes because they're supporting all of the benches all around the stadium, we want this line to get copied with all of them too. Now, it's still just a unit line. It's just 1 unit long. We'll deal with that in just a few minutes, but we know now that the line is going to be positioned properly, meaning that it's going to be in alignment with tube number 1, and that's beautiful. So let's go ahead and set up a couple of groups so that later in time in our network we can get back to these points. So first tube, I'm going to take the line and let's draw a larger representation of it right here. And we know that this is point 0 and this is point 1. I'm going to create 2 groups. One group where I am going to group both our points, so the entire line. And this is going to be very important later on, because now that we are channeling our tube and our line into our network, we're going to get to a point where we're going to need to remove the line back out and let the tube kind of finish off the way it needs to be done. But at that point, that line will have been copied around to all of the different bleachers or benches, and we can then branch off in a different direction and use that information.
And that's a technique we've seen before, at least once, when we had the center point of our character that we brought in with our character, allowed it to be affected by deformations, and then split them both back off into 2 separate branches of the network.
You got it. So we've got one group that represents the entire line, and then I'll just call it group 1. And then we've got group 2 that is going to represent just this point. Because in the end, we know that the top point is going to be positioned properly. We've already positioned it properly. He's lined up right underneath our tube, and he is 2 units down. In other words, the space of each of our rows from top to bottom. So as far as Y goes, everything's great. As far as X goes, everything's great. So I'm going to put this bottom point in a group so that we can get back to him later on as well. So coming out of this line, we're going to go into group 1, put the whole thing into there. So group, and I'll just put a 1 over here. We know that's group 1 and what it's doing. And we'll come down from there into group 2. And we'll call that 2, and we know that in this group we are simply holding 1 point.
Cool.
Now, if you remember, our tube comes out and into a material node where Steve assigned a very simple shader to all of the tubes. And then from there, what did we do? We ended up going down into a merge. We got them all set up and all that good stuff. So that's right before we transform them over. We come down here into a merge.
Because we want to merge our line and our tube together, we're going to create this merge such that we can then use both the line and the tube when we transform off to get the other end, and then we'll merge all of those back together and it will go through the rest of the network. So by creating a merge, both the line and the tube are going to be affected together.
Exactly. Now I'm just going to draw an arrow indicating that now it's going down through the rest of the network that we have at the moment, which means, as we know, we branch off, we take this tube and we duplicate it by, well, I call it duplicating, but we transform it over so that it is sitting on the other side. But now, since the geometry that's being transformed contains the line as well, we have a line sitting over here too. So if you guys don't mind for just a second, I'm going to kind of clean this up so we get something that looks just a little bit better for those of you that may be taking notes. So now that as we duplicate the tube over to the other side in the x-axis, we now have 2 lines like such. But here's the cool thing. If we were to take a look at group number 1, what's in group number 1? We have both of these guys now. Very cool. What's in group number 2? We can now quickly gain access to both of these guys. Now, of course, we go on down through the network and all, and sooner or later we end up coming to the copy benches for our rows. So that is where we're going to copy our completed bench, which now comes with 2 lines that are 2 units down in the Y direction. So further on down the network, let me just pick a place I want to do. Well, maybe right here. We come into that copy, and this is copy. I'm just going to put 4 rows. So that's going to duplicate all of our benches up our very first row. So that gives us, how do I want to draw this? So this gives us our very first set of, I'm making this up real quick, bear with me. Are you starting to see it, Steve? Please say yes.
I'm seeing where the diagram's going.
Good. So here we are, benches.
Do you want to throw 4 rows on there instead of 3 so we match with what we were drawing earlier?
Yeah, absolutely. So that guy's a little high, but I think everybody will get the point. So this guy's actually going to come up 1 unit back and over. So
cool.
There you go. And a very small erase just to kind of clean this up like such. Excellent. All right. Now, with that, keep in mind we had our lines copied. First guy doesn't mean much to us. The second guy doesn't mean much to us. The third guy, ooh, look at that. He comes in right at the bottom. And, of course, if we were to look at the underside, the other one's going to come right up underneath it. And then our fourth one, ooh, perfect. And, again, looking up underneath, he's going to come down right. So now we have lines positioned in the proper place, and that's fantastic. Now, in the network, we end up going off of the copy benches for rows down into a copy column. So we end up copying all of this around. But why copy these guys all around when we can finish them? Let's go ahead and what I'm talking about are the support beams. Let's finish the tubes and then let the tubes get copied around with the benches. So we know that right now this guy is going to basically come out and I'll just erase this real quick. He's going to run over here to another copy, and that copies us around to all of our different columns. Well, that's fine, but how about before we do that, we come over here into a delete SOP, and we use group number 1. As a recap, everyone, what's in group number 1? The entire thing. And we simply say, kill out what's in group number 1. So what happens, as far as the data flowing through the network in this direction, all lines are gone. Excellent. Now, and again, as Steve's pointed out, we've already seen this technique. Let's branch off in this direction, run through a delete, and isolate those lines. So over here, we're going to delete everything except for our support line. So I'm just going to put isolate support lines. So if we were to look at visibility right here, we would find a series of lines, 2 by 2, stacked going upwards all the way up to the top. Okay, so very good. Now let us go ahead and drop on down and delete out the first 2 sets of lines that we no longer need. Again, remember, we don't need lines up under our very first row, and we don't need lines up underneath our second row. Those wouldn't make sense. So can we gain access to those quickly? Absolutely. We run into a delete SOP. And in the delete SOP, if we were to look at all of our curves, again, this is kind of what you're seeing. Yes, Steve, what you got?
I was just going to point out, so maybe some of the point numbers that we're going to have.
I was actually going to draw it.
Oh, fantastic.
So if we, basically, here's what we're going to see. Something along the lines of this. So in this case, all right, fine, just in case Steve was to ask for it. There, we've got all 4 rows.
Thank you very much.
So we've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so those are the points. If in this delete SOP, I basically set it up to say, look, delete out points, so we're going to tell it to kill points, and let's delete out 0 through 7. So I'll just put 0-7. What's going to happen? That point gets killed, that point gets killed. As a matter of fact, let's have some fun with an eraser. That point's killed, this point's killed, so that line's gone. Point number 2, point number 3, that line's gone. Point number 4, point number 5, that line's gone. Point number 6, point number 7, that line's gone.
Fantastic.
We have just eliminated the first 2 rows of lines, which is exactly what we wanted to do. So we've gotten rid of this guy, and we've gotten rid of that guy.
And it's briefly worth noting, we could combine both of our isolating support lines and deleting those first 2 rows on one delete stop, but just for clarity, so everything's nice and clear, we've broken it down onto 2 separate delete stops.
Absolutely. So now that we're left with only the lines that we truly need, we need to go ahead and account for the fact that we have, basically, let me go ahead and draw this out. I'm going to erase for just a second and make this a little easier to see. A 1 unit line, which works out great for us on this first one, doesn't work out so great for us on the next one, and if we were to go up even higher, this guy, of course, would only be 1 unit too. We need for all of our support poles to go all the way down to the ground. This is so easy to do. You have seen this operation. If we wire out of the delete into a point stop, we all know that we now have the ability to access the position attributes of our points. And we've done that when we did the averaging and all of that good stuff earlier. So coming into here, I can simply say, all right, look, what we're going to do is, first of all, talk only to group number 2. Well, who was group number 2? Group number 2 was this guy. He's the bottom point. So now we're talking to this bottom point, and this bottom point. If we were to simply turn around, and we know that we have for the position an X, Y, and Z, and by default in the point stop, you see the expression $TX, $TY, and $TZ. What if we went in and just affected our translate Y, and instead of it being $TY, which just says let the point be where the point is at the moment, what if we were to change that to 0? Now we pull this point down to 0. This guy's already at 0. We pull this point right here all the way down to 0. We've just caused all of our support poles to sit on our construction plane, which is fantastic. So now we just need to see some sort of cylindrical shape, some sort of tube, because our line's not going to be very usable. Interesting thing is we could make it usable, add an attribute, give it some width, and make it render out.
Yeah, that's very interesting.
But we won't do that. We're going to give it some geometry right here in the viewport for everyone to see by quickly coming in and creating a circle. And we can simply run this now into... I am running out of space real fast, guys.
I think we should be fine.
We are. Right here, we're going to run this into a sweep, with our circle being our cross section, and then our backbone being the data that's coming in here, the curve that represents the support itself. And then coming out of the sweep, now what we can do is come all the way back up. So after the delete right here, remember we were going to run down to copy to all of our columns next. How about before we do that, we run into a merge. I'll just put MER. And coming out of the sweep, what if we were to take the, that's coming out of the sweep, guys. What if we were to take coming out of the sweep, plug that in right there. Now all of our benches that have been copied each of the rows have proper supports up underneath that extend all the way down to touch the floor. And our first 2 have been eliminated. So now our first column is beautiful. So if we run these into a merge, and then from there the merge goes into the copy, I'll just put CPY columns. That's COL, not COUL. So copy to columns, and now that's going to take both our benches and the supports and duplicate them all the way around. Done. This is what we're going to do. Now, we're still doing a great deal of whiteboarding, and again, we're still working towards doing a little less and a little less because, again, a lot of this stuff is seen. I thought it would be really nice in this particular case to trace through the logic that's being used to generate the position of these support beams. So with that, I guess it's time for us to jump over into Houdini and spend about 5 minutes into making it actually work.
All right, so let's jump over into Houdini.
Okay. Wait a minute. Stop. Before you jump over into Houdini, there's one thing I want to say. I'm just looking at the numbers that I've got drawn up here right now, and I want to point out real quick that I actually went backwards.
Oh, when we numbered up all those lines that we had duplicated?
When I had these guys and I went 0, 1. Ah, that's excellent. For anyone that caught this, do you see it?
Yeah, I caught it. I just didn't want to say anything.
I made such a big deal a few minutes ago of pointing out that the direction is negative. And since the direction is negative, come on, which way are they going to go? 0, 1, 2, 3, like such. No big deal. It doesn't change anything that we've demonstrated. It's still going to be 0 through 7 that will get deleted.
Yep.
Sorry, I was just looking at the 8 and 9, and right above it, I'm looking at the 0 and 1. I'm like, well, wait, the numbers are flipped around. Sorry about that. Okay, now
no worries, man.
Over into
let's
Houdini.
jump into Houdini. And the first thing I'm going to do is undo unwiring that merge, and then I'm going to create our line swap that's going to be used for our template line. So I'm going to come over here, over near our tube, since we know we're going to merge in with the tube. I'm going to drop down a new line swap. So I push tab to bring up the tab menu, type line, enter, and enter. And let's rename this to something like bleacher support pole template. And we've already seen some of the parameters we're going to use on this guy. We want our direction to be a -1 in Y. We want our origin in Y to be -2, so that we start 2 units below the origin. And we want to take our origin in X and set that to the translate X of our tube. So if we come over to our tube, we've got our center X parameter. I'm going to right click on him and copy him. If we come back to our line, I'm going to right click on our origin X and come down to paste copied relative references, just because the actual parameter is called TX, which can sometimes be confusing because it's labeled with center.
Right.
But this is actually TX, TY, and TZ. So we've got our line. Now in the viewport, this is not going to look correct. This is due to the fact that our tube is running through a system whereby this copy is driving its translate X, because its translate X reference the size X of the box. The size X of the box is what we were controlling with stamping. Our line isn't wired into the copy, and because of that, it doesn't get cooked correctly when the tube is cooked because of the copy. So we're going to see as soon as we get this guy wired in and it's run through the network and we cause it to recook because we bring our visibility to the copy, everything in terms of translate X is going to fix itself.
Okay.
So don't worry that at the moment they're not lining up in X. So we've got our line. I'm going to run him into the 2 groups that we need to reference the various points. So let's wire this into a group. And that first group that's going to have everybody in, I'm going to name support poles group. I'm going to give the group name the same name, so support poles group. And I'm going to set to group points, and that's going to group both of our points. The next group's going to group just the bottom points. I'm going to right click, grab group from our history, left click on him, and enter to drop that into our network. And this guy I'll rename to group bottom points and give the group a name of bottom points group. Again, we're dealing with points. As we saw on the whiteboard, in this case we want to only group point 1. So in our pattern, I'm going to group point 1. If we bring our visibility down, there we go, we're grouping the bottom point. So that's all the work we need to do at this stage in the network. So I'm going to take our line that has the groups created, and after we've added a material to our tube, I'm going to wire in a merge and feed in our group into the merge. So I'm going to right click on the output of the material, and I'm going to create a new merge, enter to accept that, enter to drop that into our network, and let's just create a bit of space, tidy things up a bit. And I'm going to rename this to merge tube and support template. Let's move these guys up here, and I'm going to take the output of our group bottom points, left click on that, and left click onto the input of our merge, so that we now have our tube and our line merged together.
Now you may be wondering to yourself, why didn't the line move over now? Because it's being pumped through the network, so it should have the information. We need to
basically force a recook. And to do that, if I bring our visibility down to our copy, there we go.
Beautiful.
So now all of our size X of the boxes are getting set, so the tubes are getting set, so our lines are getting set.
Let's go ahead and turn off our point numbers.
And let's, if I come over to our, where we have our stadium as well, and template that in, we'll see that these 3 guys are perfect, and these 2 rows we do need to kill out because we don't need them.
Right.
And we've seen where we're going to deal with that. In between our copying for a single row.
You can also show the columns copied all the way around too.
Yes, we can.
Look how nice that works. Everybody just goes along for the ride now.
But instead of having to deal with eliminating all of these guys at the bottom and then working with them there, if we work with them with just a single row, things are going to be a lot simpler. So I'm going to give ourselves some space to work in between these 2 copies. And then I'm going to wire a delete after this copy to delete all of our lines, then branch off to isolate just the lines. I'm also going to untemplate our stadium by templating this copy and then untemplating this copy. So I'm going to right click on the output of the copy and wire this into a new delete SOP, enter to accept that, enter to drop that into our network. I'm going to name this delete support lines. We're going to be deleting points, and the points that we want to delete are going to be our support poles group, so all of our lines. I'm going to middle click to branch off and create another delete now so that we can isolate those lines. So let's middle click on the output of copy benches for rows, create another delete SOP, left click to accept that, enter to drop it into our network, and I'm going to rename this to isolate support lines. Again, we're going to be deleting points, but in this case we're going to be deleting the non-selected points. So we're going to select our support poles group and delete everybody else. So now that we've got these guys isolated, we can deal with deleting the first two rows and then creating some thickness and setting the bottom points onto Y. So I'm going to right click and wire another delete SOP, and I'm going to call this delete first two rows. Bring our visibility down here. Again, we're dealing with points, and we're going to delete by range on this case. We do want to select one of one, so we're not doing every other point in our range we specify. Our start's going to be 0, our end is going to be 0.7. We can see when we bring our visibility down, 1, 0, 2, 3.
Yeah, so, alright, read it right. See?
Wow.
0, 1.
0, 1, 2, 3,
Yeah.
4, 5, 6, and 7 are our first two rows.
That's right.
By setting a range of 0 through to 7, and making sure we select every one that's in that range, we delete out our first two rows, which
Perfect.
is exactly what we need. So now let's wire into a point SOP, deal with getting the bottom points all set down to 0, and we know that 0 in Y is the bottom of our stadium, because we've been creating it sat on the construction plane. So I'm going to wire into a new point SOP, and on the point SOP I'm going to set TY to be 0, but we want to make sure we specify only the bottom points. So let's grab our group and grab the bottom points group.
Nice.
Fantastic. So now all we really need to do is create some thickness to these guys, and we're going to do that by creating a circle and sweeping the circle along these lines. So I'm going to drop a circle into our network. I'm going to rename this to support pole circle. I am going to link up our radius in Y, so it's driven by the radius in X. And I do want to go ahead and promote up radius X to our asset, because this is going to allow us to control the thickness of our poles. But before I do that, let's get the sweep in place and then promote that up so we can actually see the effect it's having. So I'm going to drop in a new sweep SOP, enter and enter, and we're going to have our circle as our cross section and our line or lines as our backbone. If we bring our visibility down to the sweep, we do need to make sure on the output tab of the sweep we skin unclosed, and set our circle to NURBS so that it actually knows how to deal with the information to create a skin. Currently the radius is far too large, but I'm going to middle click and bring this down slightly, and we can see the effect. I'll turn off point numbers as well. See the effect that the radius control is going to have on our supports. So I'm just going to quickly promote him up to our asset.
Okay.
So I'm going to right click on our bleachers asset in the path gadget, come down to type properties, and on the type properties page with that open, I'm going to right click on our radius X and export parameter to type properties. I'm going to rename this to support pole radius, and I'm also going to change the parameter name to support pole radius. I'm going to lock it at 0.001 minimum, and I am going to move this up into the folder with all of our other geometry related parameters. With that I can accept, and if we bring up our parameters, we now have support pole radius with control over our radius. I'm going to change the maximum because a maximum of 10 makes no sense whatsoever. So let's close that out, right click, bring up our type properties, grab our support pole
I bet you that
radius.
maximum of 10 could work if you use the overall size of the bleachers.
Well, the way we're creating this, those tubes are going to be scaled as well.
True.
So
that's true, because they're about to get pumped back through
exactly.
that.
So then they get scaled even further, and they'd be massive. So even 1's going to be kind of large, but I'm going to leave it at 1.
Okay.
As a maximum, which should give us a much Yeah, it's a much nicer feel on the radius. So we've got our sweep, and we've got our copying all of our benches around. So let's wire a merge in before we take our single column of benches into our copy, and we can take our single column of poles into our copy as well. So I'm going to right click on the first input of the copy and create a new merge, enter to accept that, enter to drop that into our network. Let's just create some space. And I'm going to take the sweep, left click on the output of the sweep, and wire that into the merge SOP as well. So now we have our benches and all of our support poles for everything apart from the first two rows.
Okay.
That's going to get copied around for all of our rows.
Nice.
Sorry, for all of our columns.
Yeah.
Merge back in with the stadium. And here's what we were talking about a second ago. Everything's going to get scaled by our overall height and overall depth. And finally, made to sit on the floor object. So that's everything we said we were going to cover. And I'm going to quickly throw in a
bonus
shader.
material. All right.
So I'm going to create the shader first, then come in, throw in a material SOP, assign the shader to our tubes. So let's hunt down our bleachers shop network. I'm going to double click to jump inside, and we're simply going to use a Vex super material, throw a very quick shader onto these guys.
Okay.
So I'm going to push tab to bring up the tab menu. I'm going to type Vex super material and enter to accept that, enter to drop that into our network. I'm going to rename this guy to something like M_bleacher seat poles. No, that's a guy that we've already made. Bleacher support poles. I am losing my mind. We are going to set these to be blend because I want these to be a metallic type material. Very dark diffuse colour. Sort of a dark grey. Somewhere around there, Phil?
Yeah, that's alright.
Feel something cool? I'm going to lower the specular a little bit. I don't want these to be too shiny. And I'll probably boost the diffuse rough a little and the specular rough a little. Again, I'm quickly throwing together the shader. I'm not spending a lot of time rendering and tweaking, because you need your lighting in place to really tweak your shaders anyway.
That's right.
So I'm going to jump back up to SOP level. And after we've swept that first set of tubes, I'm going to right click and wire in a material SOP. Enter to accept that, enter to drop it into our network. And I'm going to select from our bleachers shop our M_bleacher support poles, making sure to export a relative path. If we accept that, bring our visibility down, these guys get that material applied, which when they get copied around, everyone has that material applied. So when we look at our final transform node, they've all got the material applied. In following with our other shaders, I'll promote up their parameters to the asset, and then we're going to be done.
Sounds great.
So I'm going to right click to bring up the type properties, and I'm going to create a new folder up under shaders, and this folder will be called, let's call this stadium supports. And I'm going to, underneath stadium supports, I'm going to come over to create parameters from nodes, open up our bleachers asset, open up our bleachers shop network, open up our bleacher support poles shader, and from the shader folder I'm going to grab diffuse color, control grab specular color, diffuse rough and specular rough, and I'm going to make sure that we're not prefixing the name or the label. And with those selected and our folder selected, I'm going to click on the right arrow to promote these up to our asset. With that, if we click accept, right click and bring up our parameters of our asset, we'll see the stadium supports folder with our parameters for our stadium support shader.
Outstanding.
And with that, that's everything. I guess I can play with the parameters, show all of the
show
supports
how well
getting
it's working.
created. Yeah, exactly. So let's take something like, well, let's take a side view to begin with and play with the rows. So as we start increasing the rows, we get more and more of these guys. If we end up with 2 or 1, we don't get any. And then as we start increasing and decreasing the columns, we're going to get more and less of these guys as well. And we also have control over the radius.
Yeah, that's very nice.
Cool. So yeah, that's really going to wrap up everything I wanted to show in this video. Have you got anything you'd like to add?
No, I guess the next video we're going to go ahead and kick off the start of our crowd simulation.
Yeah.
Get our crowd all situated on this. It's going to take a few videos. We'll work our way up to it.
Yeah, it's going to be an interesting system.
Yeah, but in the end, we'll have our crowd happily distributed along all of the seats, and that's going to be fantastic. So that is going to wrap up this video. Thanks a lot.